language. And so depending on your level of understanding of VHDL, if you're new to VHDL and you're not really sure as to the full functionality of VHDL and how it differs from your standard software-based, sequential-based programming languages like C++ or Visual Basic and whatnot, how they compare to VHDL or Verilog as a hardware description language. So you can go into this page that I have set up, and I talk about all the fundamental concepts of VHDL and what it is, and throw out a lot of diagrams and references, and it's just good to check out depending on where you're at. So if you're at an introductory level to VHDL, I definitely recommend you check it out. But if you're comfortable with it and you just want to move on, then by all means you can just skip ahead. There's a couple of textbooks that are recommended for this project, Rapid Prototyping of Digital Systems, and there's a few of these textbooks out there. There's one of the first versions that came out in early 2000, and they had two revisions that came out, and that's this book here. And I've got these links here to Amazon for you if you're interested in buying them. But the latest one is the SOPC edition, which is what most college or university professors will recommend to you, and it's a great asset to have because it has a lot of information regarding the VGA controller and also interfacing to VGA-based technology, and it reviews all that, and also has a lot of VHDL and Verilog demonstrations for you to check out, working with a VGA controller and doing this Pong project. Now the difference between the way that these books portray their VHDL code is that they have it portrayed as all in one VHDL file, whereas the project that I'm laying out here, and is popular in various colleges and universities, and different professors will choose whether to use this approach or not, but that is to break the code up into blocks so that you're only dealing with one small section of code at a time, and then you interface those graphically within your VHDL software to connect them all together, and then end up producing a VGA controller and your Pong game. So it's working at it in steps, and then eventually putting it all together. And I find that approach works really well. That's the way I was taught, and it's a really good approach to work at the project. So as you can see here, this is a small little GIF animation image, which is essentially what your end result Pong game will look like. And so you got your two little paddles, the bouncing ball, and a little indicator screen there, winner. And depending on how far along you get and how quickly you can get your code up and running, you can add various additional features to your Pong project, like a scoreboard or time limit, sound effects. You can even add a video game controller, game pads or a joystick type thing to connect to your game controller and have Pong controlled by two players using these game pads. And so hopefully this project will allow you to do that and allow you the time to implement those additional features. So that's the goal of my tutorial, is to try and act as a catalyst and speed things up for you a little bit. Now, we're going to be doing this tutorial lays out the project using the resolution of 640 by 480 at 60 hertz refresh screen rate. And that's sort of the default standard for this project. However, for those of you that want to use a higher resolution setting, 800 by 600, 1024 by 768, or even higher, there's some specific timing requirements and signal requirements to implement that and change your resolution setting. So I've got a link here which will provide all of those clock frequency settings and all of the timing signals that are required to implement various resolutions. And so this page has quite a few all the way up to high def and even higher. So it's here in case you want to try and implement that and implement some higher clock frequencies other than what's available on the D1 board. So it's up to you to figure out how to do that, but it's there in case you want to try that. Now the tutorial can actually apply to different development boards other than the D1. The DE2 is a popular one. Depending, your college might supply some boards for you, or your university program might have them in stock in the hardware that they provide. Or you can use older boards such as the UP1 or UP2 development board from Altera. And there's even older boards, which a lot of colleges tend to have in stock. And there's these PLDT2 models. And a little bit more work involved because you have to interface your own DB15 VGA port to the I/O pins and implement your VGA controller that way. So feel free to do that. For those of you that want to go full out, customizing your own off-the-shelf CPLD or FPGA chip that you buy, you can use what's called a universal programmer or a designated programmer by Altera called an APU or an MPU. These are a little rare, they're a little harder to come by. They're very rare. However, colleges and universities might have them in their stock, and so you can use those to program various CPLDs and FPGAs. Now, one approach, which is actually probably a lot of you will be more interested in this feature because of how cheap it is. If you go and buy an Altera or an Nextlink CPLD from DigiKey or another supplier, and you get your part in, you can wire up your own CPLD or FPGA socket to your breadboard, and as long as the chip supports what's called a JTAG interface, and what this is a series of 4 to 5 pins, and as long as you hook up your VCC and ground lines to your chip providing power, and depending on the chip, it might have several VCC and ground lines, so you have to make sure you connect all of them up in parallel to your power. And then all you do is interface the JTAG pins, these designated pins that are on the chip, and interface those to this little $15 programmer. It's a little USB programming device called the USB Blaster, and that's by Altera. And there are other ones available, but essentially what it is, it supports what's called a JTAG interface, and that's these 4 or 5 pins plus your ground and VCC. It allows you to interface directly to the CPLD or FPGA, and then you connect your USB Blaster